Okay, we will continue on the last chapter in assembly language instruction, which is control transfer instruction. So this instruction will cover two instructions, which is jump instruction and loop instruction. So on the jump instruction, we have two types of the jump instruction. So we have unconditional jump instruction and another one is conditional jump instruction. So the unconditional jump instruction, we have the instruction of JMP. This is unconditional jump instruction. And another type of instruction, we have conditional jump instruction. We have jump equal, JE, JA is jump above, JS is jump sign, JAES jump above or equal, JC is jump carry, JB is jump below, JCXZ is jump if CX is 0, and JBE is jump below or equal. So we will look on the unconditional jump instruction first. So the unconditional jump instruction will cause us an unconditional transfer to the target location inside the code statement. So the syntax of the unconditional jump instruction, we have JMP and then we have the target or label. So the target or label is your the destination, target yang you will jump. So it will cause the IP to fetch an instruction from the given location by the target. So we look at on the example. So we have JMP instruction here, and then we have the label or target here. Kita ada the name of the label here is loop forever. So macam mana kita nak identify this instruction belong to the label mana? Biasanya kita akan letakkan the target tu di dalam satu location yang sama macam kita buat if else selection. So kalau kita tengok if else selection, kita ada if and then kita ada conditional. Katalah A equal to 2, this is the condition of the if instruction, and then all the instruction inside ni kita akan letakkan dalam group. Kita akan cover dengan the braces kat sini. So and then we have all the instruction here. So all the instruction here is belong to the if instruction. So same goes to the jump instruction. So the label here, the target here, this is the punya label dia. So and then all the instruction belong to this label. Kita akan letak dia di dalam satu group yang sama. Kita akan separate by the double column ni. So and then we have the instruction of move num1 03. So num1 is the variables, and then we have move ahead 04. This is the destination of x, and then we execute jump loop forever. So once we execute this instruction JMP, so since this is the unconditional jump instruction, so apa yang dia buat? So automatically dia akan jump to the target ataupun the label dia. So dia akan find the label dia, di mana label dia berada. So kat sini label dia adalah loop forever. So what the instruction inside the loop forever, kita ada these three instruction. move num1 03, move AH 04, jump, loop forever. And then dia akan process this loop instruction. So this program will execute infinitely. And then all the unconditional jump instruction for this unconditional jump instruction does not affect any flags. So apa yang dia buat, dia hanya bergerak ataupun dia hanya jump to the location dia sahaja. So the another type of the jump instruction, we have conditional jump instruction. So on the conditional jump instruction, we have 8 instruction inside the conditional jump instruction. So the conditional jump instruction will jump to the location depends on the condition. That's why kita panggil ini sebagai conditional jump instruction. So the jump instruction, this instruction will jump to the location ataupun will jump to the target depending on the condition yang dia dah setkan dekat situ. So we have the condition for we have jump above. Yang what you have to do is you have to remember this condition ni. This table ni you have to remember sebab kalau salah value of the flags ni, dia akan menyebabkan your sama ada awak jump ke ataupun tak jump. So dia akan menyebabkan proses tu sama ada betul ataupun salah. So ingat dia punya condition dia. So we have jump above. The condition for jump above, carry flag equal to 0 and 0 flag equal to 0. So macam mana nak dapat dia punya carry flag or 0 flag ni? Make sure carry flag and 0 flag must both is 0. So macam mana nak dapat dia? Dia depend on the previous punya instruction. So katakanlah the previous instruction, the value of carry flags and then the value of 0 flag both is 0. Then the condition, the instruction, the process of jump instruction, dia akan jump to the location depends on the target mana yang dia dah set dekat jump instruction tu. So kita ada jump above, carry flag equal to 0 and 0 flag equal to 0. Jump above or equal, carry flag equal to 0. Jump below, jump if the carry flag equal to 1. Jump below or equal, jump if carry flag equal to 1 or 0 flag equal to 1. And jump equal, jump if the 0 flag equal to 1. Jump sign, jump if the sign flag equal to 1. Jump carry, jump if the carry flag equal to 1. And the last one, okay, for the last one, kita tak tengok flags, but we will look on the value of CX, your register CX. Jump if the value of register CX equal to 0. So we look at on the instruction bar, the jump instruction one by one. So the first one is jump above. The instruction, the syntax for the jump above instruction, we have here JA and then we have label. Label ni apa-apa saya beri label bergantung pada soalan. So jump above and then we have label. So the instruction will execute if the carry flag equal to 0 and the 0 flag equal to 0. And then this instruction will cause the instruction pointer to fetch an instruction from location given by the label, and this instruction does not alter any flag. Dia just sama ada dia nak jump ataupun dia tak nak jump, depend on the conditions. And then dia tak akan ubah apa-apa flag, dia tak akan ubah apa-apa register. So, kita tengok example. For this example, we have move AX 1, 0. So the value of AX is 0, 0, 1, 0 here. So no flags will be affected for the move operation. And then we have compare AX 0, 5. So sebelum ni kita dah belajar the comparison instruction will perform the sub instruction. So this instruction does not affect the destination register. So the value of destination register remain as the previous. So X equal to 0, 0, 1, 0. But we will perform the sub instruction. The value of X is 10. 10 will be minus to the 0, 5. So kita buat dekat tepi sikit kat sini. 10 minus 5, we will get the result of 5. So how to find the carry flags and the 0 flags? So, kita tengok result is 5, 0 flag equal to 0. Result is 5, carry flag equal to 0. Macam mana nak dapat carry flag? Kita tengok 10 tolak 5. Jawapan dia tidak lebih daripada 2 digit. So, since dia still on the 2 digit value, not more than 2 digit values, this one is 1 digit. So, the carry flag equal to 0. And then, the third instruction, we have jump above instruction. And then we have the level of module 1. So this is your level. So jump above instruction will jump to the module 1 if the carry flags and the 0 flags equal to 1. Both carry flag and 0 flag compulsorily must be 0. So then the instruction will jump to the module 1. For this case, so carry flag equal to 0, 0 flag equal to 0. So we will jump to the module 1. So once we jump to the module 1, all the instruction after the jump instruction, kalau kita tengok kat sini, kita ada not AX instruction. So this instruction will skip. Kita takkan execute this instruction once dia dah jump to the module. Tapi kalau dia tak jump to the module, we will execute this instruction as well as the module instruction. So the instruction will execute from the above to the from the top to the bottom, daripada atas ke bawah. Once kita dah jump, maksudnya kita akan skip the rest instruction. So kita akan jump to the module 1 and then execute the instruction inside the module 1 instruction. So this one is the instruction inside the module 1 instruction. So kalau kita tengok kat sini, dia punya the way kita tulis the instruction, dia mesti akan extend ke dalam sikit daripada dia punya level dia. So kita akan dalam module 1 ni punya instruction, we have sub AX 02. So value of 0010 minus 0002, we will get the value of 000E. So and then kita akan execute XOR AX. Kenapa ada kosong kat depan ni? Sebab dia bermula dengan huruf dekat sebelah dekat dia punya value. So the value is FACE. So just ignore the value of 0. This is the way macam mana dia nak tulis dalam EMU nanti. Dia kena letak 0. So just ignore the 0. XOR-kan the value of AX with the FACE. So AX equal to the latest value of AX is 0, 0E. XOR with the FACE, you will get the result of FACO. FACO will save in the destination register, which is AX. And the next is the next instruction to be executed in this instruction. So we continue with the another jump instruction, jump above or equal. The condition is carry flag equal to 0. The instruction will jump to the label if the carry flag equal to 0. Dia hanya tengok pada carry flag saja. Kalau carry flag equal to 0, then dia jump to the instruction. So kita tengok sama juga. Example yang sama macam tadi, cuma kita tukarkan the third instruction ni, instead of JA tadi, kita gunakan jump above or equal. So jump above or equal, the condition is if the carry flag equal to 0. So kat sini carry flag equal to 0, it will jump to the module 1 and execute all the instruction inside the module 1. After finish the instruction inside the module 1, kena ingat dia tak balik semula dekat not AX, tapi dia continue with the another instruction after module 1 ni. So this one is skip. So the next is instruction is jump below. The condition for jump below is carry flag equal to 1. Then dia akan jump to the next to the target label dia. So on this instruction we have move AX 05. So AX equal to 0005. Compare AX 10. So the value of AX is remain the same as the previous. So we have 0005. But we do the comparison instruction. So the perform sub instruction 05 minus 10. So 05 minus 10 dalam kalkulator, bila tekan 05 minus 10, you akan dapat F5. This is the value yang you akan dapat once you use the calculator to calculate 05 minus 10. But apa yang kita tengok, kita hanya tengok the 4 digit ni sahaja untuk dapatkan the value of flags dia. Okay. Tapi since dia nak tengok dia punya carry flags, so jump below, the condition is if carry flag equal to 1. So kalau tengok dekat sini, macam mana kita nak identify carry flag kalau dia punya jawapan lebih daripada kalau untuk case ini, this is 16-bit instruction. So kalau dia lebih daripada 4 digit, kat sini kita dapat calculator ada 8 digit. So means automatically carry flag equal to 1. So jump below module 1. So this instruction will jump if the carry flag equal to 1. So kalau kita tengok kat sini, carry flag equal to 1. So this instruction meets the conditions that carry flag equal to 1. So dia akan jump to the modul 1. So for the not AX ni dia akan skip. So dia akan execute sub AX 02 and XOR AX FACE. So for sub AX 02 dia akan dapat value of AX is 0003. 0005 minus 0002, you will get 0003, and then 0003 XOR with FACE, you will get the value of AX is FACT. So this is example. If the jump below instruction does not meet the condition. So move AX equal to 05, AX equal to 0005, compare AX 05, AX equal to 0005, but the comparison instruction will perform the sub instruction 05 minus 05, you will get 0, 0. So 0, 0, the carry flag equal to 0. So jump below instruction will jump to the target locations if the carry flag equal to 1. Since the carry flag equal to 0, so dia tak akan jump to the instruction. So apa yang dia buat? Dia akan execute the not AX. So we will try use the EMU to check the result for the jump below instruction. So kita type on the EMU, move AX 05 hexadecimals, and then compare AX 05 on hexadecimals, and then jump below module 1, then not AX, then we have module 1, and we have sub AX 02 hexadecimal, and then we have XOR AX FACE hexadecimal, and then example we have another English 23. So we try to emulate. So and then we do the single step one by one. Move at 05, move compare X 05, and then the next step is jump below. So kalau kita tengok dekat atas ni, jump below, dia yang di highlightkan adalah not AX, means dia akan go to the not AX. After kita tekan lagi sekali, dia akan perform the not AX. So kita akan try buat not AX, and then the next dia akan tetap masuk dalam module 1, this one, and then dia akan execute module 1 tadi. Kita tengok, and not AX, value AX is FF FA. And then kita akan buat XOR. And then akan buat next step. So, katakanlah tadi kita gunakan the previous example, this one. Kita try on the EMU. Okay, 05 minus 10. Right, emulate, and then single step. The first one is 05, move x 05, x equal to 005, and the next instruction compare x 10, so x equal to 005. The value of carry flag equal to 1, and then dia akan execute. The next instruction to be executed is jump below, since the highlight is jump below module 1. So jump to the module 1 if the carry flag equal to 1. Dia akan tengok, dia akan once the execute the highlight value, dia akan pergi ke module 1, dia akan skip not AX ni. So the next dia akan buat sub AX 02. So akan dapat AX equal to 0003. And then akan buat X or AX FACE. So kita akan dapat AX equal to FACD. Dan kalau tengok dekat sini, dia tak akan kembali kepada not AX ni. Dia akan continue the instruction after the module 1 punya instruction ni. Dia akan terus continue. Dia tak akan patah balik ke belakang. So apa yang dia buat, dia akan continuous the instruction. So dia akan perform at AH23. Dia akan buat 1DCG. This one. And then dia akan jumpa INT21. Dia akan deactivate the interrupt instruction, interrupt flag. Okay. 1. Okay, jump below or equal. Jump to the level if the carry flag equal to 1 or 0 flag equal to 1. Since dia ada or dekat sini, maksudnya either one. So, let's say your carry flag equal to 1 and then your 0 flag equal to 0. Dia akan jump to the instruction. So, if the carry flag equal to 0 and 0 flag equal to 1, so dia akan jump to the instruction. So, kalau the carry flag equal to 1 and 0 flag equal to 1, then dia akan jump to the instruction. Cuma kalau carry flag equal to 0 or 0 flag equal to 0, baru dia takkan jump to the instruction. To the label je. Carry flag. So, this is the example. So, kita tengok dekat sini. Sama macam previous example. So, kita cuma bezanya kita tengok dia punya flag dia. This one, flag dia. For the jump below or equal, the condition is if the carry flag or 0 flags equal to 1. So, dia akan jump to the module 1. So, untuk case ini, carry flag equal to 0, 0 flag equal to 1. So, dia meet the condition. So, dia meet the condition. So, dia akan jump to the module 1 punya instruction. This one, this two instruction. So, the next instruction, the next jump instruction, we have jump above instruction. So jump equal instruction. So jump if equal instruction will jump to the level if the 0 flag equal to 1. So, if the 0 flag equal to 1, dia akan jump to the label. So, example here, kalau kita tengok kat sini, 0 flag equal to 1. Jump if 0 flag equal to 1, dia akan jump to the module 1. Tapi kalau the 0 flag equal to 0, so dia akan pergi dekat not x. So since dia meet the conditions, so dia akan skip the instruction not x ni. So dia akan perform the instruction inside the module 1. Okay, the next instruction, we have jump sign instruction. So jump sign instruction will jump to the level if the sign flag equal to 1. So, macam mana nak tengok sign flag? 5 minus 10. So 5 minus 10, we will get F, 5. So, and then kita akan tengok pada since dia adalah 16 bit, so kita akan tengok 4 digit F, 5. The most significant bit dia adalah di depan sekali ni, F ni. So convert F ni ke dalam binary 1, 1, 1, 1. So kita tengok bit yang hujung sekali ni berapa dia punya value dia, 0 or 1. So make sure 1 digit on the hexadecimal equivalent to the 4 bit in binary. So this one. So kita dapat the value of sign dia adalah 1. So sign equal to 1. Jump sign if the sign flag dia is equal to 1. So this case it meets the condition of the jump sign instruction, so it will jump to the module 1 and execute all the instruction inside the module 1. Then it will skip the instruction of not x. And then jump carry will the instruction will jump if carry instruction will jump to the level instruction to the labels if the carry flag equal to 1. If the carry flag equal to 1, that can jump to the instruction. So you still remember what the STC punya instruction. So we have here move x 10, x equal to 0, 0, 1, 0. Kita ada STC, we have CMC, and then kita ada CLC. This one is set carry flag. This one is complement carry flags, and then the last one is clear carry flag. So STC carry flag equal to 1. CLC carry flag equal to 0. CMC carry flag equal to depends on the previous value of the carry flag. If the previous value of carry flag, the current value of carry flag equal to 1. So after executing CMC, carry flag equal to 0. So if the current carry flag equal to 0, after executing the CMC instructions, so carry flag equal to 1. This is the complement carry flag. So the previous class we will discuss on this condition codes, STC, CLC and CMC. So STC will set the carry flag equal to 1. So jump carry module 1 will jump to the module 1 if the carry flag equal to 1. So this instruction meets the condition carry flag equal to 1. So this instruction will jump to the module 1 and will execute the instruction inside the module 1. Okay, the last instruction in the jump instruction, we have JCXZ. So jump if counter register 0 instruction. So the JCXZ will execute the instruction if the value of registered CX equal to 0. So on this instruction, kita tak tengok flag tapi kita tengok on the CX register. So CX register equal to 0, then dia akan jump to the instruction. So basically this instruction is used to prevent, is used on the when we perform the loop instruction. Since the CX instruction, CX register is the counter register, so it prevent the instruction from entering the loop instruction if the CX equal to 0. So dia tak nak supaya lepas CX tu, kalau CX tu 0 masih lagi masuk dalam loop, so dia gunakan JCX. Kalau CX dia 0, so dia akan jump to the instruction yang lain. So kita tengok example je. Untuk yang ini kita akan ada value of CX dekat sini. This is compulsory sebab dia gunakan register CX untuk check the value. Kalau tak ada register CX, besar kemungkinan all the instruction tu salah. So move AX 10, so the value of AX is 0010, and the move CX 01, the value of CX is 0001. And then decrement CX. Decrement CX means your destination register will decrease one value. So CX minus 1, so kita dapat CX equal to 0000. And then we have the instruction of JCXZ module 3. So apa yang kita dapat kat sini? Kita ada CX value is 0000. So JCXZ module 3 akan check if the CX equal to 0, and kalau tengok untuk for this case CX is 0, then dia akan jump to the module 3. So dia akan perform the add AX 15. Okay. And then we move to the last instruction. We have loop instruction. So dalam loop instruction kita ada loop LOOP and LOOPZ. Loop Z. Okay. First kita tengok on the loop instruction. So the loop instruction ada LOOP, and then we have level. Okay. Untuk tadi kalau jump instruction dia jump to the level. Tapi untuk loop instruction dia akan loop on the level. Kalau sebelum ni you all dah belajar on the C++, bila dia buat looping, bila kita buat looping, so bila kita buat looping, so apa yang kita buat, so kita akan perform, kita akan execute the instruction tu beberapa kali bergantung kepada berapa banyak bilangan dia nak looping. Okay, dalam C++ kita ada sentinel loop, and then we have counting loop. Tapi dalam assembly language kita tak ada sentinel loop. Cuma kita ada counting loop. So, kita boleh tahu berapa bilangan loop itu sebelum proses loop berlaku. So, macam mana kita nak tahu berapa bilangan loop? Bergantung kepada value of CX. Kalau value of CX, biasanya value of CX akan banyak. So, every time ada perkataan LOOP ni, automatically the value of CX akan decrement by 1. Automatically. So the number of times the instruction is executed depend on the value of CX. And then the loop instruction, the loop LOOP will decrement the value of CX and execute the set of instruction until the CX reach 0. So sampai CX ni dapat value CX equal to 0, 0, 0, 0, then dia akan stop the loop instruction. So basically, we will use JCXZ for checking the value of CX. So if the value of CX is 0, the loop will execute 65535 times. So kita tengok example. So actually this example, this one is the process there. So the instruction for this example only kita ada this instruction move x 20 h, and then we have move cx 10, and we have unconditional jump JMP repeat, and then we have repeat label, repeat. Inside the repeat, we have 8 AX 2H, and then we have exchange AH AL, and then we have another instruction. We have loop instruction, loop, repeat, and then the last one we have 8 AX 50H. Okay, untuk this instruction, the first one dia akan execute move AX 20. So then dia akan dapat 00 to 0. And then the next instruction we will execute move CX 10. So we will get CX equal to 000A. So kenapa dapat A? Because of 10 is on the decimal. So dia akan dapat A. Convert to the hexadecimal, so you will get 000A. So kalau tengok dekat sini, berapa banyak yang dia nak loop bergantung kepada value of CX. Untuk kes ini dia akan loop sebanyak 10 kali. So berapa banyak dia nak loop bergantung kepada value of CX dalam decimal. So kalau dia dalam hexadecimal, you have to convert into the hexadecimal punya value, to the decimal punya value. And then kita ada okay, kita dah dapat 10 kali, dia akan repeat, and then kita ada JMP repeat. So dia akan unconditionally jump to the repeat punya label. So kita ada dalam repeat, dalam label repeat, we have add AX to H, exchange AH, AL, And then we have loop repeat. Okay, the first instruction inside the repeat, the label repeat. So kita ada add ax to h. So ax equal to 0022 0020 plus 2, kita akan dapat 0020. 0022. So kita dapat dekat sini 0022. And then we have instruction exchange AH AL. So kita ada AH equal to 00, AL equal to 22. Exchange maksudnya tukarkan, kita swap the value 22 dalam AH, 00 dalam AL. So we will get 2200. Tukarkan kedudukan AL dengan AH. So kat sini di antara AL dan AH. So the new value of X is 2200. And then every time perkataan loop ni dia execute automatically, dia akan tukarkan the value of CX. Sebelum ni 000A, bila jumpa je LOOP, automatically the value of CX will decrease by 1. So we will get the new value of CX 0009. Dah decrease the value of CX, then dia jumpa level of repeat. So pergi balik dekat repeat. This is the first loop, and then this is the second loop. Second loop, same action yang dia akan perform. So dia akan buat this loop sampai awak punya CX dapat 0 here. Okay, kita tengok on the loop yang ke-9 dekat sini. So loop ke-9, CX equal to 0001. Dia perform AX 2H, dia akan dapat 2A, 0A, and then exchange, you get 0A, 2A, and then dia perform loop. Loop, dia akan decrease the value of CX. So the new value of CX will be 0000, and then the loop instruction to the level repeat, dia akan jump to the level repeat balik bila value of CX is not 0. Since the value of CX dekat sini, lepas dia buat loop instruction, dia dah decrease value of CX, dapat value of CX 0000, and then dia jumpa repeat, dia takkan pergi dekat repeat. So dia akan check, okay, check 0000, dah CX dah sampai 0, so dia akan stop the loop instruction. So dia akan pergi dekat the next instruction. So the next instruction is add AX 50. So what is the loop Z instruction? The loop Z instruction, we implement do loop and while loop or until loop. So loop Z will decrement the value of CX and check if it is 0. So loop Z will branch to the target address if the CX is not 0 and the 0 flag is set is equal to 1. If the CX equal to 0 and 0 flag equal to 0, it will execute the next instruction after the loop instruction. So, apa yang dia buat? Dia akan pastikan the CX is not 0 and the 0 flag equal to 1. Kalau the CX bukan 0 dan 0 flag equal to 1, baru dia execute the loop instruction. Kalau tak, dia akan continue with the next instruction. Okay, kita tengok macam mana buat process of loop Z. So the first instruction, move X 10. So X equal to 0, 0, 1, 0. The next instruction, move BX 10, BX equal to 0, 0, 1, 0. And then the third instruction, move CX 05, so CX equal to 0, 0, 0, 5. So dekat sini kita dah tahu. So this loop instruction will loop the operation 5 times. So supposedly 5 times. And then we will find the next instruction, JMP repeat, unconditional jump to the level of repeat. So automatically jump to the repeat levels. So inside the repeat level, kita ada sub AX BX. So AX equal to 0, 0, 0, 0, 0, 1, 0. BX equal to 0, 0, 1, 0. Bila buat proses of subtraction, 0, 0, 1, 0 minus 0, 0, 1, 0, we will get the value of AX is 0, 0, 0, 0. Then the carry flag equal to 1. So, and then the next instruction is loop Z. So in the loop Z instruction, the condition on the loop Z instruction, so kita tengok the condition of loop Z instruction, your value of CX is more than 0 and the value of 0 flag equal to 1. Kita tengok sini. Okay. Every time kita jumpa perkataan loop, automatically we will decrease the value of CX by 1. So we will get the new value of CX equal to 0, 0, 0, 1. 0, 0, 0, 4. So untuk the case yang pertama, kat sini N. So untuk case yang pertama, CX greater than 0, so dia dapat true. Untuk case yang kedua, 0 flag equal to 1, so dia dapat true. True and true, we will get true. So we will continue the loop instruction and we will go to the repeat instruction. So next we continue the repeat instructions. So we will perform sub AX BX. So sub AX BX means we will minus 0, 0, 0, 0 minus 0, 0, 1, 0. So we will get the value of AX is FF F0. And then the 0 flag equal to 0. Since dia ada value dalam result of subtraction tadi. So and then kita buat proses of loop Z repeat. Every time jumpa perkataan loops, automatically decrease the value of CX equal to 0, 0, 0, 3. So check the condition sebelum kita nak decide kita nak repeat ataupun kita nak loop ataupun kita tak nak loop, kita check the condition. So checking the condition, CX greater than 0. Untuk case ni kita buat kat sini, CX greater than 0, so this is true. Allah, CX greater than 0, this greater than 0, so dia adalah true. And then 0 flag equal to 1, this is false. So true and false, so sini and, so true and false, you will get false. So bila dia false, dia takkan repeat the condition. So dia once dia tak repeat the condition, walaupun dekat sini masih lagi sepatutnya dia kena execute 5 kali, tapi since dia tak meet the condition loop Z tadi, so automatically dia akan stop. Kalau dalam C++, kita panggil proses ni, kita buat proses break. Ada instruction break dalam C++, dia akan terus automatic break the instruction, then dia akan execute the next instruction. So the next instruction is add x 10. Okay. So int instruction, this is the interrupt instruction. So interrupt instruction, we have the number between 0 to 255. So every number, each number will represent the specific interrupt routine. But basically on the software interrupt, kita akan guna int 20 and int 21. Both interrupt instruction is used to stop the software ataupun software instruction daripada dalam orang punya EMU punya software. So kita gunakan int 20 and int 21. Kita ada 256 number of interrupt instruction. Right. That's all for loop instruction. Kita try untuk buat loop instruction menggunakan EMU. Kita gunakan this instruction. For example, move x 10, move bx, move bx 10, and then move cx. Move cx untuk identify the number of loops. Okay, and then kita buat jump. This one kita tak pakai repeat, kita pakai jump modul je, JMP modul 1. Then this one kita delete modul 1 sub x bx. And then loop module 1. And then kita buat add x 23 h. Okay, and then we have emulate. Kita tengok kita ada flag dekat sebelah sini. Okay, untuk case yang ini kita tengok loop dulu, and then after that kita akan tengok dia punya loop Z. Step by step, the first one move x 10, so x equal to 0010, move bx 10, bx equal to 0010, and then the third instruction move cx 05, cx equal to 0005. And then jump module 1, so kita akan jump to the module 1. So jump module 1 will perform move ax bx, so kita akan execute move ax bx, ax equal to 0000, so kat sini 0 flag equal to 1. Then loop module 1, so akan dapat dia akan pergi to the module 1. So, kalau saya turunkan dia ke bawah, sekejap. Turunkan dia ke bawah, boleh nampak. Kita boleh balik. So, dia akan pergi to the module 1 instruction. Insert the module 1 punya instruction. So, dia akan execute, dia akan dapat. And then, dia akan execute loop module 1. So, apa yang dia buat? Automatically, bila perkataan loop, dia akan execute CX equal to 0004. Then, dia akan pergi balik dekat sub AX. Buat lagi, dia akan dapat AX equal to FFF0. And then, dia akan execute CX equal to 0003. Since dia gunakan loop instruction saja, so dia akan loop sebanyak 5 kali. So dia akan continuously loop until the value of CX will become 0. So kita tengok di sini. So bila dia perform loop module 1 on this step, CX equal to 0001. So saya tekan single step, so dia akan dapat CX equal to 0000. So dia takkan execute the module 1 ni. Dia takkan jump to the module 1 balik, but dia akan continue to the next instruction, which is add AX23. So we get the new value of AX is FFE3. So flex, kita akan tengok di sebelah ni. Okay, and then kita try on the loop Z instruction. So saya tukar dekat sini, instead of kita gunakan loop instruction, kita gunakan loop Z instruction. So kita try emulate balik semula. So the single step 0010, and the third step is 0005, and then jump to module 1, and then execute sub x bx. So on this instruction, the value of x is 0000. The value of cx is 0005, and then the value of 0 flag equal to 1. So kita buat loop z instruction. After executing the loop z, dia akan decrease the value of cx equal to 0004. Since they meet the condition, the cx is greater than 0 and 0 flag equal to 1, so dia akan execute sub ax bx. So dia akan execute sub ax bx. And then after executing sub ax bx, the 0 flag will change to the 0. 0 flag equal to 0. Then dia akan execute loop z. Loop z supposedly jadi 3, cx equal to 0003. Tapi since the 0 flag equal to 0, not 1, so dia akan skip the process of looping and then continue with the next instruction at AX23. So dia akan buat the last instruction 0013. Okay, that's all for the loop instruction. So you all dah habis all the assembly language instruction. Alright, thank you.